In the last video, we saw the science behind the sky appearing blue. But the sun and the part around it change their color during sunrise and sunset. What leads to the reddish-orange color of the sun and its surrounding area at these times? We had seen in our last video that scattering of blue light is what makes the sky appear blue. The white light from the sun strikes the air molecules and the molecules then scatter this light. The light which has a shorter wavelength compared to the size of the molecule will be scattered the most. So violet and blue colored light will scatter the most. But the amount of blue light emitted by the sun is sufficiently greater than violet. Also, our eyes are more sensitive to the blue color than the violet color. Hence the sky appears blue to us and not violet. But then what happens during sunset and sunrise? Do the molecules stop scattering the blue light at those times? Not at all. The air particles scatter the light as usual. So what is it that causes the sun and the part around it to take the yellowish red or the reddish orange color? What we need to know is that the sun is directly above us at noon. However, during sunrise and sunset, the sun is at the horizon. So the light in the first case takes lesser time to travel as compared to the second case. During sunset, the light has to travel a longer path to reach us. But how does this argument help in explaining the color of sun at sunset? We know that the atmospheric gases scatter the light of shorter wavelengths such as violet and blue. However, when the light is traveling along a longer path, it has to interact with the atmosphere for a much longer time. Hence, more light of shorter wavelength gets scattered. It turns out that when this light reaches us, it is stripped off of most of the smaller wavelengths. Hence, much of the light waves that reaches our eyes correspond to the yellow, orange and red colors. And this is why we see the sun and its surrounding area as yellowish red or reddish orange.